Hello, and welcome to this recorded demo of 1Spatial's Police Data Quality Hub. My name's Phil, and I sit in the government team at 1Spatial UK, and I take the lead on the UK Blue Lights accounts. 1Spatial have been around as a company for a few decades now, and we are a GIS and data quality and data management company. We primarily work across government, utilities, and transportation, and have offices in the US, UK, France, and Australia, but clients globally. In government, the main sectors that we work across are central government, so organisations such as the Environment Agency, DEFRA, national mapping agencies such as Ordnance Survey, and the MOD. And in the past year, we've been moving into helping with the blue lights in the UK. So the offering that we've got for the UK Blue Lights, which you can see on the screen in front of you, is the Emergency Services Data Quality Hub. This sits on top of 1Spatial's rules engine, which is a positive rules-based approach to data quality. And I'll talk a bit more about what that means in the future. The apps that you can see on the screen are the ones that we've currently got on offer, and these have been designed with emergency services forces for the emergency services. And we have a unique innovation process where we work with our member forces to look at what are the current data quality problems that are causing them concern, and how can we find a resolution for them. And we do that. We innovate and design the new apps based on a series of demos and workshops. And because all of these apps are based on no-code rules technology, we can spin up new apps to sit on the hub here in a matter of months, which means we've got really rapid, agile, and innovative approach to building up these apps. The three that you can see on the left-hand side of the screen are the ones that are currently available on the hub. So we've got address and coordinate correction, address and UPRN correction, and beat boundary updates. These are the three that are already available. Address and coordinate correction takes all of your police data and it checks that the record is in the correct location for the address that it's in. So what it will do is it will take a record, look up against the authoritative government source, which often tends to be data from Ordnance Survey, and it will check that the record is first of all within a property or on a street record, and then it will check that the record is at the same address as the polygon it is within. So for example, if you had a building that was a burglary that was recorded at 1 Acacia Avenue, but it was actually within the building for 5 Acacia Avenue, this would come up as being incorrect. And the reason we need this is because often when you open up police data, if you look at it, or emergency services data, if you look at it on a table form, the address can be correct and it will all look okay. But as soon as you put it up onto a GIS mapping system or a business intelligence dashboard, because the geocoding and the coordinates are wrong, all the points will go off to the wrong location, and you'll end up with false positive hotspots or incorrect hotspots, which can lead to inaccurate deployment of resources. If there is a record that is not within the correct building or on the correct road, what this app will do is it will then shift that record to be in the correct location, and it will also do an address matching check to check that there's no spelling mistakes or any address errors on the police record or the emergency services record. So that's the first app that we've got, the address and coordinate correction. The second one looks at addresses and UPRNs. So this takes a similar approach in that it's looking up against the government source. But here, rather than the coordinates, we're focusing on the UPRNs. And the UPRN is a unique reference number for any addressable location. So if you took, for example, a flat within a building, that can be described in lots of different ways. It could be flat 1, flat A, ground floor. And then there's obviously different ways of describing the building. So you don't always have an exact way of describing the location, which can make it difficult to link multiple data sets or multiple systems, particularly if you're looking at doing something in a machine-readable language. Where the UPRN comes in, it provides every addressable location with a unique number. So what we're doing here in this app is we're taking any of the emergency services records and we're checking them against the authoritative government record, and we're then saying, okay, each of the emergency services records must have a UPRN, and the UPRN must match the UPRN on the government record with the same address. And what it will then do is it will go through a series of confidence levels at the address match, and then if there's any errors in the emergency services record, such as spelling mistakes, it will go back and fix those based on the government data. The beat boundary update app, this one, as patrol boundaries or beat boundaries are constantly changing, This takes any records, checks which beat boundaries is within, and then will update the data if it has changed. So each time that you redraw your beat boundaries, rather than having to go through and manually change all of the different records depending on the new beat area they're within, this will just automatically run it through by doing a spatial check. And the final one you can see on the right hand side, this is one that we've got in development with a few of our member police forces at the moment, and this is looking at updating street records when there's local alias names. So for example, if there's a local unofficial name that isn't in the address record, such as Bleakwood, people might be calling in a traffic accident on the A41 at Bleakwood, for example. Unless the local officer has knowledge of where that is, it's then difficult for command and control to dispatch someone to the correct location because the alias names aren't factored in the data in the command and control system. So what this app does is it takes any of the local alias names and it will update the street records with any alias names each time they're updated. So there you can run through your entire county's road network in a matter of minutes and update against all the alias names. So and the way that this hub is licensed is it's licensed on a per app basis. So not every force will need every single app that's made available to them. So what we do is we price this per app, so then you're only paying for what you need, which hopefully means you can resolve your strategic priorities without having to fork a large bill for things that you're not going to use. We're trying to be flexible and dynamic, and with our innovation team and our innovation process, the app library is constantly being updated and evolving. As well as the apps that are made available, we've also got user management here, so you can see there's different, you can register people based on their name and different users, and we can also assign people to different teams. So you can have the 1Spatial team, or you could have a police force submission team, or a department's submission team. And you can make certain apps available to certain teams. So if there's an app that's handling sensitive data and you only wanted it to go to one team, you can make sure that team are the only ones who are able to access that data. And we can also then start to look at who is submitting data, which teams are submitting which data via which apps. So as well as here the overall view, you can see which one I demo the most. You can also then start to narrow it down, so we can look here at different particular apps. So we want to look at the this app and then get up a certain team. So we can start to get different statistics. How many data quality rules are they breaking? How frequently are they submitting data through? So we can start to measure the ROI of those applications. So the app that I want to demonstrate to you today is the UPL Ren one that I mentioned earlier. And I just want to open up some data here to demonstrate to you what the data looked like beforehand. So you can see here, this is some data that we've extracted out from Niche, and the UPRN here, there's quite a lot of gaps in the fields here, which if we're going to start trying to link our data sets together, is going to be difficult. So if I open back up the hub, so what we're going to do is we're going to load up that file onto the UPRN app. Now I should say there's different ways that you can deploy this. You can either deploy it with a loose connection, such as the one I'm demonstrating today. So you've got your data in your records management system, and what you want to do is extract that out of the records management system, maybe using SQL or something like that, run it through the data cleansing app here, and then put it back in manually as well, if you don't want this running on live data. You can also connect this directly to live data. It's data agnostic and process agnostic, so you can connect it in, and then you can click a button to run it. Or you've got a very close connection where it's connected to the live data, and it will also just constantly run in the background anytime it detects any changes to the data. But the one we're demonstrating here is we're going to have a look at the loose connection, just because it's the easiest way to show the before and after. So we've got our data here in a CSV, and we're going to load it up. And we know that the data has come from a Niche record management system. So we're going to say that we're expecting it to be Niche, and we're just doing some schema checks here to make sure that everything lines up, and it does, so we're all good. So we've kicked off the rules engine now, and the rules engine is in 1Integrate, and the way 1Integrate works is it takes a positive rules-based approach, and that's a key thing to highlight here, because the positive rules-based approach means that you're saying this is how I want my data to be, and if it isn't like that, then it is not good enough. So that's an important thing to mention here, because if you were trying to hard code this in, you would have to flag any records if. So you would say flag it if it's this, flag it if it's this, and you're constantly then having to think of every single way the data could be wrong. And there's a chance if you're doing that, the data could slip through. So what we're doing here is we're saying this is how it's got to be. If it's not like that, then make sure it is. So what we're doing now is we're loading the data up. We've got just shy of 80,000 records there, and we're loading it up into a cache. That's because whenever we're running any of these checks, we want to give you the opportunity to say, yeah, I'm happy with that before we push it back in, with an obvious exception if you're looking at the live data option that I mentioned earlier on. What we're then going to do is we're then going to run some data pre-processing here. So that's just making sure that both data sets are in capital letters, for example, and making sure that there's anything to do with the multi-occupancy buildings as being mapped out as we need them to do. Then the first check we're going to do is this confidence level of 6. So we've got different confidence levels about how confident we are that the UPRN and the address is correct. So 6 is the highest one. This is the most confident we can be. So what the rules are going to do is they're going to go through all of the records, and they're going to say, okay, for every record that has an exact match, so the addresses are exactly the same in the emergency services record as they are in the authoritative government data, and the UPRN is all correct, mark that one as checked, all okay, and give it a confidence score of 6. Nothing to do here, all okay. What we then do is we then process on to confidence level 5, and we're going to say, okay, for all the records that haven't already been checked at level 6, if the UPRN is missing or incorrect, but the addresses, so everything else in the address fields are exactly correct and all okay, then pull the UPRN from the government source over to the emergency services record and mark it with a confidence level of 5, and then also tick that something has been changed. We then follow the same logic, but there's a slight tweak in the rules for the sub-premises number, which is why there's a different layer there. Level 4 then says, okay, for everything that's not been given a confidence level 5 or 6 that has been checked, now do the same check again, but what we're going to do is we're going to allow a spelling mistake. So if we're pulling the UPRN over from the government record, but there's a spelling mistake in the emergency services record. So, for example, if in the emergency services record it had been spelled a burglary at 5 Bell Lane, but in the government record it was 5 Bell, and then Bell was spelled B-E-L-L, whereas in the emergency services record it was B-E-L-L-E, then we're going to say we're pretty sure that's correct, and we're going to match it over, but we're not quite as confident as we were with the exact address matches, so we're only going to give it a level 4. Level 3 and level 2 are partial address matches, so this might be a burglary of property, for example, or another incident of property where we've only got the house number and the postcode. We're going to say, yeah, we're pretty confident with that, but we're only going to give it a 3 or a 2. And then finally, level 1 is where we were unable to make a match. So this might be where someone's just written stabbing at Greg's, and then there's no other details. We're going to say, well, we've got no idea what that could be. And rather than trying to automate a change, it's less of a risk to just flag that one up as saying this one needs looking at. What we're trying to do here is we're trying to then reduce the amount of manual checks that the team, data quality team at your force or the IT team needs to do when they're looking through the data. So if we've got 80,000 records submitted here, but we can get it down to saying, okay, well, you only need to check 200 of those, that's a significant reduction on your workload, which means then your team can start looking at trickier examples they need to look at. So we got to the end there in a matter of minutes. We've processed 80,000 records through the data quality check, and we're now going to get an output for us to have a look at. And because we're doing the loose connection, this would then need loading back into the records management system. But like I said, you can connect it directly if you wish. So if I open it up here, you remember beforehand the gaps in the UPRN. There are loads of gaps in the data. So you can now see, this is the previous one, just waiting for the new one to load. There we go. So you can now see all of the UPRNs have been filled in, apart from the odd gap, but that's where we've had a confidence level of 1. So we've now got full and complete data that we can start to do to create linked data between multiple different data sets and start to bring up a rich picture of what's been going on, whether you're investigating a crime, responding to an incident, or if you're trying to allocate resources for the future. You can see here we've got the confidence scores as well. So another thing that we can do is we can also filter out. We might say, okay, anything with a 6, 5 or a 4 is all good to go. Just chuck it back or send it straight back into niche in this case, or whatever your records management system is. But I'm going to do some spot check on some 3s. So anything that's with the confidence score of 3. So what we'll do then is we then say, okay, let's filter it out and give this to a member of the team to have a look at. And you can see here it's been ticked as processed but also updated, so changes have been made to the record. As well as the auditing that you could see on each of the records, we have got a PDF report here, and this is just to add an extra layer of transparency of what has been processed and when. So you can see here we've got the team member, admin at 1Spatial, a very original email address, and it was done on the 16th of December at 16:49, and which data was submitted through which set of rules here. So you've got further transparency there on what's happened, and then once the submission's finished, all of that will then be logged back to the dashboard for constant monitoring of the data quality across your organisation. So I hope that was an okay brief introduction. I wanted just to show you an example of some data being run through. We can go into more detail looking at how the rules are structured. It's all in no code, so you don't need to be a technical person. If you want to have a look at that, please do get in touch with me. My details are on the web page that this video is being hosted on, and I'd be more than happy to take you through on a more detailed demo. And I would also just like to invite you to join our innovation community. So those who are in the innovation community, some of them are paying customers, some of them are those who are hoping to join as paying customers in the near future, and some of them are those who are just interested in what we do and are monitoring things and like to be involved in the discussions. So if you join our innovation community, there are absolutely no strings attached, but we would welcome as many people inputting as possible, because we would like the app library that we're hosting here on the Emergency Services Data Quality Hub to be as relevant and as current for the forces who are signed up. Thank you very much for your time and attention, and if you have any questions, please don't hesitate to get in touch.